Right, good evening. In the room, many people in the lecture theatre under Plan B this evening. Lots on Zoom. What are the Zoom numbers, Richard?
We have 46. Oh no, 44 now. That was 46 a moment ago.
44. Okay. All right.
We've just
I've
lost
said
a
the wrong
couple.
thing already. Okay.
Yes. Well, they realise that there's going to be some stuff that's not appropriate for young people. So
Yeah, no under 18s on Zoom, Richard. So another interesting talk planned for this evening: psychology of disaster. I'm going to hand over to Malcolm in just a second to do the introductions for our speaker. I'm quite stressed and fatigued this week, which I believe puts me and maybe others at greater risk of disaster. Is that right? Yeah. Okay. So on that note, I'll sit down and I'll hand over to Malcolm.
Thank you, Dan. Thanks. Not quite sure I like the way that every time you mention disaster, you mention me, but however. Well, good evening, ladies and gentlemen. Welcome. I'd like to introduce our speaker this evening, Dr. Graham Edgar, who's Professor of Psychology and Neurosciences at the University of Gloucestershire, so local, for a change, a nice local speaker. Well, Graham started life initially as a physicist, tells me, but changed quickly, saw the error of his ways, and quickly became a psychologist, doing a BSc in psychology at the University of York. He then went on to do a master's in research, psychological research methods with the Open University, and he is now the Vice
President of their Student Society.
Vice President of the Student Society of the Open University. So all you OU students, here's your man. And then latterly a PhD in visual psychophysics, more about that later, at Keele University. I think Graham's got that nice combination of working in the private sector and in research and academia. Worked for some years at the BAE establishment in Bristol. I think I'll leave it at that, actually, and leave you to talk about the psychology of disasters.
Okay, thanks very much. Can everybody hear okay if I talk at this sort of volume? Is that okay? If I start to fade out or stop or anything, just give me a wave. If I start to talk too quickly, again, ask me to slow down. Sometimes when I'm filled with the joy of cognitive psychology, I tend to speed up. So do ask me to slow down if it's going too fast. First of all, thanks for the invite. It's always lovely to get out and see people, really. So thank you very much for the invite. I appreciate it. I should mention that I changed from physics to psychology, partly for sort of academic reasons, and partly because in physics, the male-female ratio was 98:2 at the time I was doing it. And psychology is just so much more, I don't know, friendly. Okay, so I'm going to talk today about psychology and particularly the application, really, of psychology in the real world, which, the way I do it anyway, tends to be known as human factors. So the application of psychology to systems and to real world systems. So I'll be talking about that. Oops.
Click on the screen.
Okay, let's try this one. No. Try that little clicker thing. Is that,
Yes, if you forward and backward. No. No. All right.
forward on that one.
No.
Yeah. Okay. Thank you. I'll use this one. Thank you. Okay. Another term I'll talk about is situational awareness, which is everybody who does it has their own explanation or sort of definition for it. I tend to go with the simplest, which is knowing what's going on around you and knowing what to do about it. And it's easier usually when people have poor situation awareness than when they have good. I will tend to use the term as we go through. So I'm talking about situation awareness or SA. That's what I'm talking about. So psychology. Let's get to the basics. Really, here's your basic human brain. Wonderful advances in imaging and so on now, making huge strides. So we've found out things about it. It has about 67 to 86 billion neurons, which is a lot. Which I worked out was about 10 neurons for every human being on the planet. So we're pretty well equipped. Each neuron synapses or connects with about 7,000 other neurons. which makes the human brain is widely regarded, or arguably, the most complex object in the known universe. So because of that, you have to wonder why it thinks it's a good idea to do things like this. I really hope that's posed and not a real thing. The thing I'll keep coming back to throughout this talk is it is a phenomenally complex system. The capabilities are astonishing of the human brain. You know, I've been in this area now for hundreds of years approximately, and it still astonishes me what the brain can do and the way it operates. But it is finite, and it is dealing with a very complicated world, huge amounts of information, huge amount of things going on, a lot to cope with. And it is actually quite difficult for us to keep up with all of the information that's going on or bombarding us at any one time. And that tends to be when the mistakes are made. But start off with an illustration really of how that actually happens, or to demonstrate the fact we can't cope with everything at the same time. One of my hobbies is magic tricks. I'm in no way a magician, I should say right away. I just don't have the skill, but I am fascinated because magicians discovered much of psychology before psychologists ever got there. They were using it for years before we gave it the fancy names. So it's really interesting to study. So I'm going to start off with a magic trick, and I apologize if you've seen this one before. It's done the rounds a few times, but I do like it. And it's a card trick. I'm going to show you 6 cards. I want you to pick a card, any card. And I want you to remember it because I will try and make you forget it. So pick a card, any card. Pick a card. Already got one? Here's my beautiful assistant. This is Thompson, my cat. Keep remembering the card. And Thompson is a bit of a card sharp, as you can see, and he actually likes to eat cards. He actually does, because he likes to taste the cellophane on the cards, so he will eat them. And it's possible that he may have eaten the card that you've chosen. So I'll put up 5 of the cards again. And if it's your card that's missing, if your card is the one that he's eaten, please put your hand up. So if it's your card that's gone, please put your hand up. Okay, thanks very much. Okay, it's possible, of course, that you all chose the same card, which will be quite spooky, and that was the one I removed. But there is, of course, a much simpler explanation. Everybody know what it is? They all changed. Yeah, they all changed. To start with, oops, not too many. They're all 9s, 8s, and 7s, reds and blacks, of course. And the second set are again 7, 8s, 9s, reds and blacks, but they're all different. But the point is, of course, what happens when I ask you to pick a card, you focus on that card. That's the one you're processing. That's the one where you're putting all your effort into. And you remember there are other cards there. You've got a vague idea what they are, but not the details. So when I change them, you just don't tend not to pick up on it. I think a more powerful demonstration still, what a bit like is this one. Let's see if we can get this one to go. Let's try this. Ah, there we go. Okay. Oh, there's no sound at the moment. Let's have a look. Sorry, I'm trying to get someone in. No, it's all right. I had it earlier. Didn't have it now. Nope, should be some sound. I don't think we actually need the sound.
I have no idea what the sound on the computer is connected to.
That's weird because we had it earlier, but it doesn't have it now.
It did play music before.
It did. Let's try and see if we can get it on this one. No, that's okay.
I know what it is.
Oh, okay.
Switch the amplifier through to the other.
Ah, okay.
So that might be better.
Let's have a look. Yes.
Yeah.
Okay, I'll just take it back to the start again. I apologize for the cheesy music.
Clearly, somebody in this room murdered Lord Smiley, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place?
I was polishing the brass in the master bedroom.
I was buffering his lordship's scones below stairs. I was polishing my petunias in the rocking chair. Constable, arrest Lady Smythe. How did you know, madam, as any horticulturist will tell you, one does not plant petunias until May is out. It's just a matter of observation. The real question is, how observant were you?
There's 21 things changed, seeing the show now.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time. I was buffering his lordship's scones below stairs. I was polishing my petunias in the rocking chair. Constable, arrest Lady Smythe.
This was done as a road traffic sort of public information thing. Okay, so a sort of more powerful demonstration really of the card trick, but the same basic principle. It's called change blindness. And the idea is, of course, that you tend to focus on certain things. You focus on the subject of whatever you're looking at, the detective, whatever, and you tend to miss everything else. You're aware of it, but it's not being processed to any deep level because you don't have the resources to do it. And that's a fundamental principle of psychology, really, and something that we have to deal with all of the time, that we cannot process everything that's going on around us. And often this can be overlooked. There's this assumption that if the information is there, people will pick it up, they will process it, they will respond to it, and therefore if they miss it, then they are culpable in some way. There's a problem. It's often simply that people cannot, you cannot attend to everything. This is just the way it is. So with that in mind, let's have a look. I'll look at a couple of sort of well, incidents really, and look at some of the psychology behind them. One fairly new one, which is this one, and one quite old one. But this has been in the news a lot over the last few years. This, of course, is the Boeing 737 MAX, where two of them actually, of course, crashed. So this particular one, it took off from Addis Ababa and crashed about 6 minutes later. Remember the incident, you'll know that. What a bad crash. Both engines buried to a depth of 10 meters, crater 28 meters wide and 40 meters long. You know, this was not in any sense a controlled landing. I think the euphemism in the aerospace industry actually is not even that. It's controlled flight into terrain where people fly to the ground, which is pretty much what it was. Okay. One of the other things I look at is the difference between how and why. When you're looking at accidents and so on, it's very easy usually to work out how it happened. Somebody didn't do something, something wasn't watching, somebody made a mistake. That's how it happened. But the why it happened is often much more complex. You have to go back through the system. You have to go back through what's happened, find out why that particular person at that particular time made that particular error. So the how is easy, the why is more difficult. But the how in this case was the, you've heard of this, I think, the Maneuvering Characteristics Augmentation System, or MCAS. And the idea is, if the nose of the plane rises too high, and there's probably people here know more about it than I do, if a plane rises too high, it starts to slide backwards through the air, and it basically stalls and crashes. So MCAS is designed to counter that and push the nose down. Unfortunately, MCAS in this case cut in when it shouldn't, it pushed the nose down when it shouldn't, and it kept pushing it down until the plane actually crashed. So if you look at the flight, sort of the altitude of the plane, you can see it did a series of sort of roller coaster type ride until it finally actually went and crashed. So it kept climbing and dipping. So what caused that? Well, what it was a faulty sensor. The Boeing 737 has two sensors which tell it what sort of attitude it's in, when it's pitching up or pitching down or whatever. And MCAS took the reading from one sensor, that's important, just one of the sensors, and it used that to decide whether it needed to intervene and sort of readjust the attitude of the plane. Unfortunately, the sensor it was taking the input from was the left one, in this case, the red one, and it was faulty. If you look at the angle it was indicating, the same plane was pitched up by about 70 or 80 degrees. Well, I don't think a Boeing can actually fly at that sort of attitude. A jet fighter can, but I don't think a passenger aircraft can. But MCAS didn't know that. It decided the plane was pitching up massively, so it pushed the nose down. But of course, it wasn't pitching up that much. So it pushed it down, started to lose height. The pilots tried to correct it. They tried to bring the nose up again. MCAS just cut in again, pushed it down again, and they fought each other for a while until finally MCAS won and the plane crashed. So just the timeline there. One of the things the pilots tried to do, and this was part of the procedure, was to actually turn off MCAS and control the plane manually. The trouble is, when you're trying to control the plane manually, you're fighting against the physical forces over the flaps and so on, and they couldn't physically do it. So the only way they could do it was to bring the electronics back online again to control the flaps. And as soon as they did that, MCAS cut in again and carried on doing what it was doing. And Dagmar Whitmudge is there saying they followed the procedures, but they simply couldn't bring the aircraft back into control. Okay, let's have a look at why MCAS was there. This is how the accident happened. MCAS cut in when it shouldn't, overruled the pilots, and it crashed the plane. Why was MCAS there, and why did it sort of misbehave? Well, here's a quick quick spot the difference for you. On the left there is a Boeing 737 MAX, a plane that crashed, and on the right is an Airbus A320. There's several differences between them, but one of them is important. Any idea which one?
Position.
No, not position.
Where the engine is?
Where the engine is actually, yes, it is where the engine is. Yeah, that's one of the things. There's actually something else. Yeah, no. The angle of the wings. No. The position of the engine is important. That's why MCAS is there, actually. But the crucial thing about it, and the important thing, is the Boeing 737 is more low slung. It's got shorter undercarriage. It sits lower to the ground than the Airbus A320. But you're absolutely right. The position of the engine is important. I'll come back to that in a moment. But the 737 has shorter legs than the A320. Why is that? Let's go back a bit. The 737 is actually a legacy design. It started off in about 1967, it's first launched. And in those days, the engines were like those on the left there, nice sort of cigar-shaped engines, nice thin ones. And they kept the undercarriage fairly short because they didn't need to any longer. The engines are quite thin, and they used to load the passengers through steps rather than the sort of gates that we have now. So it kept them nice and easy, nice and close to the ground. But the problem is, of course, is that the new engines are, the ones on the right there, are much more fuel efficient, but they are fatter. And because of the short undercarriage on the Boeing, they won't fit under the wing anymore. So what they did was move them forward. So they are further forward on the Boeing than they are on the Airbus. And what that did was change the flight characteristics. It tended to push the nose up and push the tail down. And that's what MCAS was brought in to correct. And speaking as a sort of human factors person, you can't actually really disagree with that, because you want to make life easy for the pilot. By bringing in MCAS, the idea was that this would make the plane fly the same way it always had. It would correct for that changing of the engines. And in theory, the idea is a good one. The thing that wasn't so good was they didn't tell the pilots it was there. I think it was buried deep in the manual, but they didn't feel the need to train the pilots to cope with it, because as far as they were concerned, nothing had changed. This new plane would fly the same way as the old one. So, which was a bit of an oversight, really. So, when you start looking at the the why side of things rather than the how, you get into this idea of what's called an error chain, or we talked about this earlier. It's rather nice what I like. So I like cheese. It's the James Reason Swiss cheese model. The idea being that in any error, any incident, there are a series of decisions or things that could have happened or might have happened that lead up to it. And they're like the slices in the Swiss cheese. And the error could have been stopped at any one of those slices. But all of the slices have holes in, mistakes, misconceptions, whatever. And those allow the error to propagate. If the holes in the Swiss cheese line up, the error propagates all the way through, and then you get the accident. So looking at the MCAS thing, the final how, the pilots couldn't control the situation, they couldn't recover the aircraft. You go back and look at why MCAS was there, and you can actually trace it right back to the fact that in the old days, the 737 just had short legs. You might say, well, rather than sort of moving the engines around, why not make the undercarriage a bit longer? Well, I worked for aerospace, and although I wouldn't claim to understand aircraft undercarriage, one thing I did learn was it's a lot more complicated than a wheel on a stick. It's an incredibly complex piece of kit. And also, you make the undercarriage longer, you have to make the bays of the fuselage longer as well. And before you know where you are, you're building a new aircraft. So that's why they thought it was easier to move the engines and to fiddle with the undercarriage. But one thing you tend to find with all incidents like this is that at some point, somebody is going to blame the pilots. It's convenient, apart from anything else, because it tidies things, being cynical, it tidies things up. The pilots make the mistake, the pilots are to blame, and as they sit at the front, they hit the ground first. So that tends to leave everything nice and neat and tidy. But this did happen quite explicitly with the Boeing one. This is Congressman Sam Graves, American, and of course Boeing is a big American company. Pilots trained in the US would have successfully been able to control this situation. So it's the foreign pilots that are to blame. One of the reasons I said before why the pilots couldn't regain control by switching off MCAS was because the aircraft was going too fast. The speed of the air over the wings was too fast for them to control it. So the one way they possibly could have recovered it, and they did try this in simulators, was to reduce speed, reduce the speed of the aircraft, take the pressure off the wings, then recover it, and then they could get back to where they were. But somebody else, Chris Brady, somebody with a great deal of knowledge on the 737, pointed out that they may have wanted to reduce thrust, but the aircraft was low and nose down, heading towards the ground. And as he put it, you'd have to have balls of steel to do so. It goes against everything a pilot would want to do. You only want the plane in contact with the ground twice, taking off and landing. If it's heading towards the ground, your natural instinct as a pilot is to, of course, pull the stick back, increase the power, get height. They always try and get height, of course, because you don't want to hit the ground. So, yes, okay, maybe there would have been a theoretical way they could have recovered the aircraft. But as Chris Brady has pointed out, you would have to be very brave to try that. So where's the psychology in all this? Well, this is Chris Brady again. Going to design and certify an airline, and with such a complicated, obscure failure mode as happened to that crew, it's no wonder that your average crew aren't able to deal with it. That actually is quite telling. Because what you've done with this particular system is introduce what's called a latent error. What's called the active error is the one the pilots make, or the pilots can't control the aircraft. That's the active problem, that's the active error. So you can build in latent errors that will sit there and catch them later. And that's what I think happened with the 737. There were all sorts of things going on the production line. For example, because certifying a plane is actually an expensive and difficult thing, you need a lot of expertise to do it. The Federal Aviation Authority didn't really have the resources to do it. So they basically came up with a scheme which basically allows the airlines or the manufacturers to certify their own aircraft. So they say, yeah, we honestly, this is perfectly okay. And the FAA then sign it off, which again is not a good thing. And huge problem, this is a massive latent error. Both 737, of course, had 2 angle of attack sensors, and MCAS only used one of them. There was a system that would monitor both and warn of any disparity, but it was only available as an optional extra. You think, really? But of course, it would cost more to put it on the aircraft. It would cost more to have it there from the start. So you save a few quid by leaving it off. And also, one of the things that Boeing said, in the sort of aftermath of this stuff, was that, well, you don't need that extra thing. You've got the pilots there; they can pick up the slack. Well, that's a terrible way to design an aircraft. So, well, if something goes wrong, with a bit of luck, the pilots will work it out. And that's where this is where the psychology comes in. Is it fair when you design an aircraft like this to assert that it was theoretically possible, with the benefit of hindsight, with plenty of time, to say that the pilots could remedy that situation? I don't think it is. There's always this danger of Superman, Wonder Woman, I think that you are relying on the pilots being superhuman, or not even superhuman, but behaving as well as the best possible person could on their best possible day. You can't design systems that way. You have to design them so that an average person on an average day will be okay, or even a bad person on a bad day, ideally. So that's the human factors. And a lovely quote there from Eric Holmnagel: human error is best understood as a judgment made in hindsight. And isn't that the truth? See this with accidents like this and a lot of other incidents and so on. And also, actually, you'll see this in the papers all the time. Anything happens, anything, a big crash, ship sinks, or it blows up, terrorist attack, anything. You'll get the report in the paper. Okay, that will be there. Probably about a week or 2 weeks later. Why, oh, why, oh, why didn't they see it before? Why wasn't this prevented before? Yes, because we know what the problem was now, but we didn't know what it was at the time. But this is what human factors, psychologists, basically try and do. We try and provide the hindsight in advance. So, so try and predict what the pilot could cope with, what the system will do, what the pilot will be able to do with that system. So we try and give the hindsight in advance. And also the other thing we do is we look at incidents and we try and analyze them without the benefit of hindsight. What could an average human being in that situation have been expected to do? Not somebody with hindsight, not somebody with more time, that person at that time. Okay, let's get back to the psychology. Another aspect of psychology, and this is my sort of stuff that I do now, really. One of the things I do now. This whole idea that, like the pilots in the 737, they were coping with a massively awful situation, complex, lots of things going on, lots of things to try and work out. And as I said right at the start, limited resources to do it. One of the things that interests psychologists generally, and me particularly, is how do we cope with those limited resources? And I'll talk about firefighting particularly for a fair bit of the talk. Limited resources, we almost have a choice. We can focus those resources on, say, a small area or a small number of items, a few things, and we can give it our full attention, if you like. We can put more effort into that sort of small area or that small amount of information. So, high resolution, if you like, small area. Or we can do the opposite. We can sort of open out, take in loads of information, try and take everything in, but we don't have the resources to process it all so deeply. So, bigger spread, lower resolution, if you like. That, by the way, is the Clarence Hotel in Exeter. I had a room booked there. It wasn't my fault. And we refer to this, or this is the term that we use, we refer to this as bias, either a narrow bias, focusing down, or a broad bias and focusing out. And to illustrate this sort of how powerful this is and how important this is, I'm going to look at another incident. This is an older one, but I use it because it's been well researched. And this is the Storm King Mountain wildfire in the United States. 1994, but this was a disaster where 14 firefighters were killed. So it's a nasty one. But just to give you an idea of what wildfires are like, hopefully this video will play. No sound on this one, so that's good. But this video, I'll point out this video is exactly 3.5 minutes long. Just a minute. This is in Australia, by the way, the video. They're doing property protection from a wildfire. The wind changed direction while they were there. You can just see the smoke starting to appear now on the right. So 3.5 minutes from beginning to end. The filming is by an actual fire truck. It was being protected by a sort of water mist system and it stayed there rather than me. So the road doesn't stop the wildfire at all. Must have more faith in their truck than I would. I think I did not stay there. They were watching out. They picked up the change in the wind direction and they they legged it, which is the sensible course. So there you go, 3.5 minutes from start to finish. So that's what you're dealing with a wildfire. Storm King Mountain was a wildfire. It started on July the 2nd, but they didn't start fighting it until the 5th because it's a wildfire. It's hard to get there. Storm King Mountain, of course, a mountain in America. You can see from the video there that wildfires are hot. They're fast. They can move 25 miles an hour. They can move faster than you can run. And they can leap large gaps, so roads and trees and so on. So this particular fire, it was on the 5th, local crews, and they sent in some jumpers. This is something I think unique to America, possibly. These are firefighters that actually parachute into the fire ground rather than me. When they hit the ground, they start their fire. But I don't know if it's still the case, but at this time, the way they decided who was incident commander was the first person to touch the ground. I assume you push the most experienced person out first, but it seems like an ad hoc way of doing it. But anyway, they were fighting the fire. The incident commander, at the start of the day, requested a spotter plane for to get a big view, to get this big picture, to work out what was going on. That was denied. There were other fires going on. They had a brief go with a helicopter. This is the fire ground, basically. This is what they were fighting. There's a pointer somewhere. So the fire was started by a lightning strike on the top of the it started here with a lightning strike, and the incident commander decided to dig a fire break along here. This is what's called the South Canyon. And that was what he decided to do. That was, which, you know, it's perfectly sensible, but it's a difficult thing to do. There was a problem though. There was a weather forecast which predicted the cold front would come through at about 3 p.m. And two main things you need for a fire, well, three things really. You need heat, you need fuel, and you need oxygen. Where you've got the heat and the fuel, you've got the trees and so on. What a cold front brings is more oxygen. And so what you'd like to get is what's called a blow up, where the fire is like to suddenly become much more intense, move much more quickly, and become hotter, basically. Unfortunately, the incident commander didn't request a weather report. Nobody told him, and he didn't think to ask for it. He also forgot to set a fire lookout. So at 6 minutes past 4, radio message for everyone out of the canyon went out, and 18 firefighters were running for their lives. 16:30, which is what, about 7 minutes later, 6 had outpaced the fire, and the others were caught, the other 12 were caught just here at this tree. If they got to here, they would have been safe. They'd run all the way along here. If they got to here, they would be safe, but the fire caught them there. And that's where 12 of them died. There's no criticism of the commander's professionalism or his bravery. The commander actually, when the call to evacuate went out, was actually at this end of the line. He could have just gone this way and would have been perfectly safe. He didn't. He ran along the whole of the line to warn the firefighters, and he was caught with the others at this point here. So the incident commander was also killed in this particular incident. So looking at it from a sort of psychology point of view, really, at the start of the day, he was maintaining what we would say this broad bias. He was taking a lot of information. He had the big picture. He was trying to keep the overview. But as the day went on, he got tired. He got fatigued. Everything got more difficult. He started to tunnel down. He started to, if you like, lose the big picture. He didn't set a fire lookout, so he didn't realise that the fire had suddenly picked up. He didn't request a weather report. He didn't have all the information he needed. He didn't have the broad picture. And by the end of the day, he was down to just saving individual firefighters. And in some ways, this change is what we're interested in. This is the research that I'm doing now. This, if you like, tendency to either try and use a lot of information, low resolution, or focus on a small amount of information, high resolution. So the big question really, these are important matters. What can a psychologist do to actually help with this stuff? Let's have a look. Got a couple of sort of projects we've been running. First one is that one, which is FireMind, and wittily titled. The second one, which just finished, is FireFront. I think it'll be Fireplace next, I'm not quite sure. These are European projects. I have to say I'm not happy about Brexit. Working with all these countries across Europe, and I have to say it's absolutely lovely working with them. They are all, without exception, lovely, lovely people. Just to give you an idea who the people are. This is the UK FireMind team or FireFront team. This is us. You may wonder why the Lego. I'll explain that in a moment. But the team is, on the left there, you have Dave Brooks, a wonderful tech guy. Steve Baker, sort of science type. Prof. Di Catherwood, who's one of the people with me who started all this. And fire guy Jeff, who retired now, was Deputy Chief of Gloucestershire Fire Service, did a PhD with us, and is now Dr. Jeff. And last and possibly least, there's me. The Lego, one of the countries we work with is Denmark. And as you probably know, Lego, of course, is a Danish company. The Danish fire service is different to ours. It's actually a private fire service, not a public company like ours, it's private. And certainly until recently, I don't know if it still is, but it was majority owned by Lego. So Lego owned the Danish fire service, and that was the only excuse I needed to buy massive amounts of Lego. That's on top of the filing cabinet. It's a fireground built entirely out of Lego. Anyway, I find it very relaxing. That's the local team. This is the European team, and as I say, they are lovely. I'm not sure there will be another project with Brexit, but we're doing our best. But what are we doing with all this stuff? Well, what we're doing is designing training scenarios, and they're basically videos. And we use virtual reality to make the videos because we are trying to make videos that are culture independent, if you like, run them across all of the partners. So we don't want anything too specific to any one country. And we interleave the little sort of probes, true false probes. And what it allows us to do is to measure people's situation awareness. And the exciting thing, which is unique to our particular approach, is we can measure and assess whether people in the scenarios that we're running are tunneling down using a small amount of information for high resolution, or if they're opening out and using a sort of broad brush approach like that. And that actually is incredibly useful to know. Because apart from anything else, what you can find is that you could have two firefighters, for example, in the same situation, and the situation awareness would be quite different. One is tunneling down like that, one is opening out like that. So even in the same situation, two people could have very different awareness, or the same person at different times, like the incident commander in Storm King Mountain. And one of the things that we're very clear on is that there is no optimal way of doing this. The whole reason you're doing this is to save resources, because you have limited resources, you just don't have the resource to put in there. But whether it's best to tunnel down or to open out, we're not going to go there because we don't think there is one particular way of doing it. So, for example, fire guy Jeff, he was Gold Command before he retired, so one of the very senior commanders. And he would always say that if he turned up at if he would have been called out for big incidents like this, if he turned up at a motorway accident, he found the incident commander with his head in the car, then something had gone wrong. The incident commander needs to keep the big picture, like the Storm King Mountain guy. He needs that big picture. The guy getting the people out, or girl, Ross possibly has more female firefighters than any county, I think. But the firefighter getting the person out of the car, they probably need to focus down. They need to be focused on right where they are, that one thing, that's what they're doing. The incident commander needs to keep the bigger picture. And Jeff would always say that the Paddington rail crash was a really good example of a well-managed incident from the point of view of the emergency services. The incident commander, when he arrived, the temptation had been to rush down there, get onto the train, get involved in stuff, get hands on. It was a he didn't. He stayed back. Standing back, it kept the big picture, and Jeff says he feels that's one of the reasons why terrible disaster, but well managed by the emergency services. So what we've been doing is we can't say we're going to push people into, say, tunneling down or using their resource in a particular way. We can't do that, because apart from anything else, when the situation comes up, people will do what they do. We won't be there. What we're trying to do is to raise awareness of this particular concept, this whole idea that your resources are limited and you can either tunnel down or you can open out, or something in between, of course. Because neither approach, or no approach is optimal, but what we want is for firefighters particularly, that's who we're working with, to be aware that this can happen, that they may tunnel down, or they may open out, whatever. And this has actually been incredibly well received by the fire service. As soon as we started doing the work, people said, yeah, this really makes sense. This really actually, I know this has happened to me in an instant. I know that I've tunneled down, I've missed things, I've missed information, like with the card trick and that sort of stuff. We've even had incident commanders that we've worked with saying they've changed the way they manage incidents as a result of the work that we've done with them. We have done the posts, but we have won all sorts of awards for this. And the approach that we're taking, the training that we're developing, is now being incorporated into the national training of Estonia and the Netherlands. They have centralized training, so they can actually do it much more easily than we can here. But so the approach we've taken, which is to measure this stuff and make people aware of it, and to make people aware of how they're using information, how they're using their resources, has been incredibly well received and is being applied, which I have to say, I find deeply worrying. Because as a psychologist, I had a blissful 30 years or so where actually nobody paid any attention to anything I said. And I found that quite reassuring. So to actually have people taking notice, I find rather worrying. But also, before I get too big-headed, perhaps I will tell you, to finish up, about my career in toilets. From sublime to ridiculous. Toilets. Before I go there, and to keep the suspense going, really, talk about something else, another aspect of human factors, and it's this. If anybody's familiar with this, this is the Hoover dustette. It's almost legendary in human factors circles. It's made by Hoover, and just after it was released, Hoover came up with the slogan, "You'll be happier with a Hoover." You may know where this is going, but the Hoover dustette also figures prominently in a particular medical paper, which is this one: penile injuries from vacuum cleaners. 4 case studies, at least 2 of which involve the Hoover dustette, which has fan blades about 15 centimeters from the inlet. Present patients may well have thought that the penis would be clear of the fan or drift new lengths by the novel experience and came to agree. If anybody wants a copy of the paper, get in touch. It's well worth a read because of the excuses that the people involved gave. Things like, I was changing the plug on the Hoover and it switched itself on and happened to catch me where it hurts. Things like that. So they are quite remarkable. Why is it interesting from a human factors point of view? Well, I was saying one of the things you have to try and do is to give the hindsight in advance. And to do that, you have to try and predict what people will do with the systems. And that can be done. I don't know, maybe, I think actually Jeff, Fireman Jeff would have predicted that this is what people will do with this system, but it's actually quite difficult sometimes to predict exactly what it is that people will do with these sort of systems. Okay, back to toilets. Here's me in a ladies' toilet in a police station in North Wales. I was helping the police with their inquiries. But I won't say anything on that. One we talk about is another project I worked on in my BAE days for aerospace. And this was the Nimrod maritime patrol aircraft. Oh, that was an interesting project. The Nimrod, of course, is based on the de Havilland Comet, the world's first civilian jet airliner. And BA got this contract to build the new sort of maritime surveillance aircraft. And to be honest, I don't think they wanted the contract, because they put in this sort of completely wacky bid that they would refit the old Nimrod. Bear in mind that this airframe, I think, was about 30 years old at the time. They would refit an old airframe and do it. And I don't think they wanted the contract, but they got it. And they were left trying to basically refit a very old airframe with all the latest stuff. And it was a horrible project because, of course, the airframes had twisted and moved and jiggled about a bit. So it wasn't as though you were building from scratch. Each one was almost bespoke, but they did a pretty good job. And my job on this was I had to do the lighting philosophy for the Nimrod, for the new Nimrod. Basically, I had to say how bright the lights were, how they were, all that sort of stuff. All the lighting stuff, really. That's the psychophysics stuff. And I did all of it. I did the cockpit, so warning lights, all that sort of stuff. I did the mission area, where all the radar and all that sort of stuff is. I did the galley, where they make the cups of tea. I did the ordnance area, where they drop things on submarines. I even did the bomb bay. I did all of that. It was a big project, and I have to say I was quite pleased with it in the end. Unfortunately, of course, as you may know, they scrapped it. It was ready to go. They were actually flying. The new Nimrods were flying. I think it was a bit of an embarrassment, the whole idea that you were flying a 30-year-old aircraft and calling it new. They just scrapped it, and very quickly. I don't think it was a lighting philosophy to blame, but I hope not anyway. But what's this got to do with toilets, which is the theme we're on at the moment? What's it got to do? Well, as I say, I did the lighting for everything. Cockpit, bomb bay, ordnance area, everything. And the RAF were perfectly happy with it. I put a lot of effort into it, and they were fine. So this is great, happy with this. one thing they weren't happy with, the lighting in the toilet. Why was this? Well, it took me quite a while to find out. So the problem was that the toilet is around about here, and it's in the same place as the lookout area. The Nimrod had a little sort of bubble window because it used to do a search and rescue, and the best way still is to look out the window sometimes. The trouble was, you often doing it at night, and the lookout would be dark adapted, because you can see better, of course, at night, with dark adapted, and that takes about 20 minutes. Unfortunately, the toilet was in the same area as the lookout area. So you're standing there, 20 minutes, you're dark adapted, somebody goes to the toilet, switches the light on, bang, there you go. It's another 20 minutes to get dark adapted again. So right, I'll be clever. You know, I'm a psychologist, I can cope with this. So I came up with what I thought was a really neat scheme. And it's like a fridge in reverse. So they open the door, the lights would go off. They go in, close the door, and the lights would come on. And I thought, problem solved. I pleased myself, really. And the RAF would not have it. They wouldn't accept it. And I couldn't work out what it was. We had all these meetings, and nobody would say. It was only when I talked to them unofficially, and this is about predicting how people use systems, I found out what the problem was. In those days, the Nimrod used to fly abroad, I suppose we're going back that way, when duty-free was well worth having. So the Nimrod would fly, land abroad, they'd stock up with duty-free, and then stack it in the toilet. So the reason they didn't want to go into a dark toilet, not because they were scared of the dark, but because they'd fall over all the cans of lager. So that was the one thing I had problems with. Now, if only I'd known about this device, then I wouldn't have had such trouble. And what I'm going to show you now, I regard as possibly one of the best pieces of human factors ever designed. This is it. Oops, click up. It's this one. The lab nav. Still available from Amazon, only about $12.50, which is an absolute bargain. You stick it under the Lucy here, and it has a motion sensor in it, and it picks up anybody going to the loo at night, and you don't need to put the light on. But the sheer genius is that if the seat is down, it projects a green light. If the seat is up, it projects a red light. And the sheer genius is if it projects a red light, it projects a target. And that is genius human factors. If I'd known about that, the Nimrod could just have had that and saved so much bother. But it's not quite perfect. Not quite. We'll finish it off. There's what the lab nav is doing. It's called basically nudge theory. Putting the target up there, the gents will like to aim for it because that's what gents will do. They'll aim for something. And nudge theory is the idea that you don't try and force people to do things. You just nudge them in the direction where they want to go anyway. And the classic example of nudge theory is the ship old fly. This was first put in by the airport manager. The cleaning manager had this idea, and they put little flies on the porcelain of the urinals. It 80% reduction in spillage, and 8% reduction in total bathroom cleaning costs, which is pretty impressive. And Richard Thaler, who got the Nobel Prize for nudge theory, said it was his favorite illustration of a nudge. There's a problem with this, that chaps get bored, and you get habituation. So yes, they'll aim for a fly for a while, and the spillage will go down. Then they get bored and they start to ignore it. So Schiphol, for example, now to sort of reawaken the interest. So going back to the lab nav, you like to habituate to this. So this is my idea, and remember, should this sweep the world, you heard it here first. Rather than just projecting a circle, you can have it projecting something of your choice. So something like the coronavirus. I did have a picture of Boris there originally, but I thought that was a bit. And even better, you could hook it up to an app on your mobile phone, and you could change the picture on your toilet to whatever you wanted. So you could keep updating it and have something different to aim at each time. So remember, you heard it here first, and I think that is the perfect human factors device. And that's the end. So thank you very much for your time. I appreciate it.
Thank you very much, Graham, for a most informative and very amusing lecture. Questions? Yes.
I think I read that the Tesla autopilot is going to offer different modes, aggressive and not aggressive and scary. Is this a good thing?
This is something that I've been pondering, really. One of the other jobs I'm talking about, I do road traffic accident investigations. It's a huge moral dilemma because, of course, you could set, what do you set the system up to do? Do you set it up to protect the driver or the people on the road? So if there's somebody with a pram going across in front of you and you've got the choice of either killing the driver or the person with the pram, which do you go for? It's long been my contention that actually all that will happen is you get what you pay for. So you can have, I apologise to any Audi drivers here, you can have the Audi option, which will just protect the driver at all costs and blow anybody else, or you have a more normal sort of setting where it will just try and balance it. But to be honest, I don't know the answer, but it's a huge moral dilemma. And from the legal side, of course, you've got a horrible thing going on there that actually if something like Tesla does hit somebody, whose responsibility is it? Particularly in this rather awkward phase we're heading to now, where you have an autonomous vehicle with the driver expected to take back control if something goes wrong. But if it runs somebody over, is the driver more at fault if they did intervene or if they didn't? Or is it the programmer of the system? Not sure the answer because I don't think there is one, unfortunately, but these are the dilemmas we're going to have to try and deal with very soon, I think. Personally, I can't wait for autonomous vehicles because, as I do road traffic accidents, and I'll be delighted to have autonomous vehicles. They're far safer. Yeah, they will run a few people over, but they're far safer than you.
I'll make a comment rather than a question. Your description of the 737 MAX reminded me of a lot of work we did in safety-related systems, safety-critical systems, and the human contribution, which could obviously also be one of your Swiss cheese layers. We looked at it as a four steps in the human activity. One was, what information are you presenting to him and how are you presenting that information? Which led to the second step of working out what the hell's going on. And then I think where the Ethiopian pilots were put on a dead loser from the start. Yeah. Because once you've done that second step and you've decided what's going on, you then get to the third step, which is the decision. What am I going to do about it? Now, of course, in many big disasters, actually, by the time you've made the wrong decision in step two, you haven't worked out correctly what's going on. You might take a perfectly sensible decision based on what you think is going on, but something actually it's not the right thing. Yeah. And the fourth step we looked at is, having decided what you're going to do, how do you execute that? And as I say, normally steps 1 and 2 are the ones that go wrong.
I think the classic example of that, if anybody remembers, it was Kegworth.
Absolutely.
Yeah, where they turned off the wrong engine.
Because the two displays were one above each other rather than left and right.
Yes, they misread the displays and turned off the good engine, which left them with no engines, unfortunately.
Well, they carried out that step excellently.
Absolutely, yeah, perfectly excellent. Unfortunately, yeah.
I always remember a colleague saying that you can never make things foolproof because fools are far too ingenious.
Yes.
How do people who work in nuclear power or brain surgery or other supercritical things, the automotive industry, deal with the fact that their systems will inevitably not work? How much preparation do they have for these Ethiopian pilots having to do something quick on the spot when the system is working, or some part of the system is just completely failed? How much thought goes into that in general?
Depends on the industry, I think, to a large extent. I almost went to work for nuclear power, or whatever they're called now, and I was amazed at their safety culture. It was one of the reasons I didn't go to work for them, because they had things like if you walk down the stairs, you had to hold the handrail. Otherwise, people would shout at you. And the idea was that the safety culture permeated absolutely everything, every single part of their sort of daily life. So they were probably better prepared than most. Things like the 737 incident, then you have to say that was much more sloppy, because they'd sort of come up with this idea that pilots could recover it, and that was part of their sort of safety planning. But they hadn't told the pilots the system was there. So when it actually happened, they just weren't really prepared to actually take over and control it. And again, from a human factors point of view, you can see the justification. Nothing changes. It keeps the plane the way it always is. So why should we tell them? But what they hadn't done was think it through to what would happen when the system actually changed. Sadly, it comes down to cost, I think, a lot of the time. Nuclear power, they tend to be very, very safety conscious because the consequences are just so high. But I know I did some work for a well-known car company. I won't say who they were, but they knew that one of the cars that they produced had a nasty blind spot, which is potentially dangerous. It could easily have been solved by modifying the wing mirrors slightly, but that would have cost a few pounds extra per car. So they didn't do it because the consequences there are, yes, you will lose a few drivers, but it's unlikely that they even get blamed for that. So the cost is quite low. So often it comes down to simply the economics. If they can do it cheaply, they will. But otherwise, just sort of propagate through, really.
Is it reasonable, though, to expect Boeing to explain a very unlikely event that might happen? Because I know a friend of mine who went off the end of the runway at Campbell, and the trim had run away, fully nose down, although the indicator said it was normal. And they went flying down the runway, didn't leave the runway. And to compound the problem, when they called for the barrier, they were told it was at the other end. And they finished up in Campbell Village. They went down the field and took the wings off. But there's no way you could expect anyone to say, oh, at some point, for no obvious reason, the trim may run full away, but the indicators say it's normal. It's too much.
Yeah, this is one of the problems with human factors, really. You cannot predict everything. You can try and predict as much as you can. And the whole idea of exploring the sort of basic capabilities of humans is to say, okay, what are the problems likely to be? And we'll try and track, Swiss cheese thing, try and fill in as many holes as we can. We're never going to get them all. There's always going to be something weird which could happen. Some really bizarre thing will catch you out. Yeah. So, unfortunately.
Working in the automotive industry, we spend a lot of time doing failure mode analyses and hazard analyses, and to have one safety critical sensor in a system is, that's happening.
Yeah, yeah. I completely agree on that one. You think that was absolute madness.
Especially if there was another sensor available.
Yeah, yeah. When I read about that, I was gobsmacked. I thought, who on earth thought that was a good idea? Or even just to have some error trapping in there. So it said that the angle that it was reading, the plane could never achieve that.
Yeah.
So just a simple couple of lines of code to say, whenever it's reading this, something must be wrong because it can't do this. Yeah, yeah.
Do you have input into simulators? Because surely simulators, all these disasters try to predict.
Yeah.
Feeding it in there beforehand. That's a great thing.
Yeah, the problem is that even simulator time, because simulators for pilots are expensive, and it comes down to the cost again. Yeah, so yeah, it's cost as always.
It was all about loss of market share. They didn't even have simulators at the time in the 737. It shows that the fact that they're still out of business, basically.
Yeah, yeah.
That's what it was all about. It's about money.
Yeah, unfortunately, a lot of it comes down to that. Is that there's always, well, in some ways, when you're talking about safety, it's always a conflict. We can make car driving much safer if we made the cars more solid, or if we reduce the speed limit to 20 miles an hour nationwide. We could cut the road traffic deaths to almost nothing. Yeah. We accept a certain amount of risk, both risk and financial cost, and we decide how much we're prepared to put up with. If you want your flights to cost twice as much, then they'll be safer.
I noticed that the developers are now blaming the government for having legislation that failed them. Where do you draw the line between personal responsibility and legislation?
Yeah, that's sort of down the line from me, really. I don't really worry about that. Once the accident happened, I sort of walk away. But no, I completely take the point. It's going back to the sort of the Tesla type thing. Who do you actually blame when the accident happens? Or if you decide there's legislation which allows them to get away with that? I think the problem is when you get sort of compromise going on, and again, it's cost. Like, for example, as we've seen with some of the current MPs, where the MPs are both sort of responsible for implementing the legislation, but are also advising the companies that are producing the goods. When you get a conflict of interest like that, you think, well, this is plainly wrong. Again, it's this systems approach, it's a Swiss cheese approach. You have to track it back and see where the errors were and what has contributed, and apportion blame, to be honest, with where the error was. So if the error was in the legislation, that's where you go for.
Isn't that why the government changed things to self-certification, for example, in the oil industry? They went to that because they were very prescriptive. You worked to statutory instruments and things like that, defining you will do this, you will do that. And then they suddenly realised what they defined incorrectly. They made a bad decision sitting in Parliament and say, okay, you will do this, you will do that. And so the oil companies could then turn around to them and say, well, you told us to do it, for example, that type of thing. And so the government said, okay, you can do self-certification. That's what Boeing's done.
Yeah.
Self-certification. So they all say, oh, fantastic, we're going to save an awful lot of money here. Yeah. They didn't realise that they're taking on the whole responsibility. So they have to set up a mitigation for running their individual aspects of the project. But if you have a bombastic boss, he's just going to say, no, I'm not going to do that. I know it's going to cost money, but I'm not going to do it.
Yeah.
That then goes away from human factors. There's an add-on. So how do you overcome that?
Well, some of it is basic psychology. And we're seeing this quite a bit with Boris at the moment, that it doesn't matter if you can kick it down the road a bit, which is what Boris is doing now. But things like legislation, so on, when it passes it down the line, by the time it actually happens, you're probably retired or you'll be moved on to another job or whatever. It's not going to be your problem. So it just gets it off your desk sometimes.
I have a question from John M. John Morgan, perhaps, who asks, was the Boeing problem not really one of corporate greed, in that the company thought it was cheaper to modify an existing airframe than start from scratch with a new airframe? I guess that question applies at many levels where they could have done things better.
Absolutely, they couldn't. Yeah, if they'd redesigned the aircraft from scratch, they wouldn't have needed the MCAS system at all, because of the movement of the engine forward, because couldn't fit it in the old airframe, basically. Yeah, so had they started, but of course, there's an intense competition with Airbus. They're constantly trying to leapfrog each other. But to step back and redesign an entire aircraft, certify and so on, would have put them at a disadvantage. Airbus could have gained market share while they were doing that, so they just had to try and keep up. So
do you get tempted, I wondered, also to do a similar analysis of catastrophes that happen in government?
Yeah, well, it's the same process. It's the same process. It's the same psychology, the same economics. Yeah, but yeah, it's exactly the same.
You also studied flukish near misses, where great success occurs and the accident didn't happen.
That's a good question. I'm trying to think if I have ever looked at anything like that. Simple answer is probably no. Actually, no, that's not true. When I was at Aerospace, we actually established a database, which was basically a critical incident reporting database, to actually do exactly that and look at the near misses. The idea being that if you can trap the near misses, find out where the problem is there, then you get it before you get the actual incident. So yes, I couldn't think of anything. We did that for ages. Yeah.
Showed the firefighter with a narrow focus, looking at the detail, and a guy with a wide focus, looking overall. My experience of working in automotive as an engineer is that engineers like myself, we always tend to work at the narrow focus, and we won't always know what our colleagues are doing, or sometimes care what our colleagues are doing, because we're so focused on what we're doing. And then you talk about a company as one entity, that one entity should have the overall view, but that entity is 100,000 people, 50,000 people. So you say, well, which employee is it that's got to have this overall view and the ability to understand that a single sensor can't be
can't fail because it's ludicrous. So that one person again would fail your being able to be all things to all men. Nobody in that business could be that person, I don't think.
I think you're absolutely right, because like the MCAS thing, you can imagine somebody whose job it was to design the system and program it and say this works perfectly. It picks up, it works perfectly. That's exactly what it's meant to do.
Yeah.
And it wasn't their job to step back and go, well, what happens if that one sensor fails, and then just slips through the cracks.
It's not his job to make sure that the pilots are trained.
Absolutely, yeah.
But nobody would have that remit to do all of that.
And when you've got a system as complex as an airliner, then in fact probably nobody could actually physically do it.
Yeah.
Would there be a case, do you think, for employing psychologists?
Absolutely. Well, obviously I'll look at that, but one of the problems I've always found with doing human factors is it's often brought in at the end. So the system is designed and then they bring in the human factors person and say, okay, do the human factors on it. Well, that's too late because the system's already there by then. You need to be in there all the way through with things like the MCAS. So, well, what does happen if it fails and what is the pilot going to have to do and can they do it? The trouble is that's expensive and also it doesn't really show because, all that happens is something doesn't happen. And so you can't make a case justification or a cost justification for it because there's nothing to point at. So it's expensive, it's time consuming, it slows things down. Much better just bang on there, produce a thing and sort it out later, which sometimes happens.
This element of looking wide in A&E in hospitals, I've been for some time, isn't it? So when someone comes in, there's only one person under control. You've got people doing specific things. One person is overlooking the whole thing.
Yeah, it's one thing one of the things we found with the firefighters that they have started doing since we've been working with them is almost to allocate somebody in the command center to actually step back and keep an eye and to actually tell the incident commander if they are starting to tunnel down, if they are starting to miss things. Because it's very easily done, of course. So, yeah.
Yes.
So I have to be closely handled service in London, and I found one of the most controlled areas. You said about the commander is like something like Citron Stadium, where still the commander is up there in the control box, actually looking down on the whole ground.
Yeah.
And we, as the bronze officers, were on the ground itself in different positions, the bronze safety and all these sort of things. Do you feel that the psychology of just like the bronze, silver, gold level has improved that operability?
I think it has, because it sort of almost defines the role that each person has. So, as Jeff was saying, that Gold Command, their role really is to take the big picture. Often even beyond the incident, they'll be doing things like even the press, things like road traffic in other areas, this sort of thing. They are really stepping back and doing the bigger thing. So yeah, I think having the different levels, because bronze, they're in there, they're hands-on, they're getting the people out of the vehicles, whatever. So yeah, I think it's actually a really good system. It defines the level people are working at. So, yeah.
One more question.
As a psychologist, are you able to identify the sorts of people who are predisposed to take the wide view or the narrow view?
Well, this is something we've been working on actually, whether people do have a natural tendency to revert to a particular, either narrow or broad. And very cautiously, we think they possibly do. But when the pressure comes on or they get tired, they will tend to fall back to what we would call a resting bias. So if they tend to go broad, tend to go narrow, they will fall back on that. It's complicated because all sorts of other things will shift it around. But we do think there may be a sort of, a resting position they'll go back to. We just haven't worked out how to tell yet.
Martin, final question.
Oh, changing tack slightly. Well, it's not a circle I walk in. Erasmus suffered somewhat from Brexit. I noticed that you were the only academic institute in a collection of industry sectors as well as public sectors. And I just wondered, where could your work go from here onwards? And, what do the European colleagues think about?
This is where you see a grown man cry. Yeah, we had two Erasmus projects, so I mentioned there, which we led both of them. There was one other university involved in Copenhagen, but it was almost entirely sort of fire services and national training things. With Brexit, we're now not allowed to lead Erasmus anymore. We can't. So that completely kills that. But what we can do is we can take part, but not as the lead.
Right.
So we are now plotting to be the power behind the throne. Netherlands will probably lead it, and we will lurk in the background. But it's devastating because the projects have been marvellous. The impact, I would say, has been really beneficial impact. Wonderful people we work with, great progress. It's just such an amazing scheme, and to have it trashed, it's really painful.
Right, well, thank you very much, Graham, for a most entertaining and very informative lecture.
Thank you.
Thank you.